In this video, we will present evidence on LPS as a food, primarily based on animal tests. Please refer to LPS as a food, Part 2, in LPS Learning 3 for evidence based on human trials. The effectiveness of LPS intake have been validated at the cellular test level, animal test level, and human trial level. Among these, we will sequentially introduce the effectiveness of LPS such as the prevention of atherosclerosis and Alzheimer's disease, prolongation of life in combination with cancer chemotherapy agents, and enhanced efficacy of vaccines in animal models. First one is a study to investigate the effectiveness of the prevention of arteriosclerosis. We used ApoE-deficient mice, which lack apolipoprotein E, a lipoprotein involved in lipid metabolism, in the study. These mice develop atherosclerosis due to increased total cholesterol. A high-fat diet accelerates the onset of arteriosclerosis. In this study, we administered LPS to ApoE-deficient mice fed with a high-fat diet to examine differences in body weight, plasma lipid and plasma inflammation markers, and the state of aortic vascular plaque. This graph shows changes in body weight. A reduction in body weight gain was observed in mice fed a high-fat diet together with LPS, compared to those fed a high-fat diet alone. This graph compares different plasma lipid markers measured 8 weeks after the start of the study. Total cholesterol, triglycerides, and LDL were lower in LPS group with statistically significant differences. However, no significant difference was observed in HDL, known as good cholesterol. The results demonstrated that LPS may control the increase in plasma lipid markers as a result of a high-fat diet. This graph compares different plasma inflammation markers measured 8 weeks after the start of the study. Although no statistically significant difference was observed, TNF, as a representative inflammation marker, tended to be lower in LPS group. In addition, MCP1 was lower in LPS group with a statistically significant difference. The results demonstrated that LPS may control the increase in plasma inflammation markers as a result of a high-fat diet. The photo shows an incised thoracic aorta with stained plaques. Now, take a look at the graph on the right, which quantifies the plaque volume. Less plaques were formed in LPS group. The results demonstrated that LPS may control obesity, increase in plasma lipid and plasma inflammatory markers, and formation of aortic vascular plaques as a result of a high-fat diet. We also examined changes in the intestinal microflora in this study on arteriosclerosis. It is known that firmicutes increase and bacteroidetes decrease as atherosclerosis develops. The study results demonstrated that LPS has a positive effect on the intestinal flora. In LPS group, where 1 mg per kilograms BW per day of LPS was orally administered, firmicutes significantly decreased as indicated by blue bars, while bacteroidetes increased as indicated by orange bars, compared to the control group. No significant difference was observed in the relative abundance of proteobacteria between the groups. Next, we present the study results on the effectiveness of the prevention of Alzheimer's disease. We used senescence-accelerated prone-8 SAMP8 mice in this study. These mice develop Alzheimer's disease as they age, and the onset of the disease is accelerated by a high-fat diet. SAMP8 mice were divided into 3 groups, including low-fat diet, high-fat diet, and high-fat diet plus LPS groups, to compare several markers in this study. These graphs show the results of the study examining insoluble amyloid beta in the brain. There are two types of amyloid beta, 140 and 142. The study showed that both types of amyloid beta increased in the high-fat diet group, and the increase could be reduced by administering LPS with a statistically significant difference. The results suggest that the intake of LPS may reduce the risk of developing Alzheimer's disease. The graph shows the memory test results. We will not go into detail about the testing method now, but assume that the vertical axis of this graph represents memory. Memory declined in mice fed a high-fat diet relative to those fed a low-fat diet. However, memory loss may be inhibited in mice fed a high-fat diet and administered with LPS. The results described above suggest that LPS may be expected to inhibit the accumulation of amyloid beta in the brain and prevent memory loss. The next graph shows the study results on the effectiveness against cancer. It shows the survival rate of mice implanted with B16 melanoma. The horizontal axis indicates the number of days, and the vertical axis indicates the survival rate. Untreated mice all died before day 25 after cancer transplantation, as indicated by the blue line. In contrast, the prolongation of life was observed in mice treated with doxorubicin, an anti-cancer drug. However, all of them died before day 55, as indicated by the orange line. Meanwhile, the survival rate of mice treated in combination of doxorubicin and LPS leveled off at 60% on day 60, as indicated by the gray line. The results suggest that LPS may be expected to improve the outcomes of cancer chemotherapy. The last study we present is about the prevention of viral infection. This graph shows the survival rate of mice infected with a highly pathogenic influenza virus. The horizontal axis indicates the number of days, and the vertical axis indicates the survival rate. Unvaccinated mice all died before day 10 after infection, as indicated by the blue line. However, the survival rate of mice that had been vaccinated before being infected with the virus was 60%, as indicated by the orange line. The survival rate of mice that had been vaccinated and had the intake of LPS increased as high as 90%, as indicated by the gray line. The vaccine used for the mice indicated by the gray line was a sublingual vaccine and not a subcutaneous injection. This means that the level of prevention is higher with the sublingual vaccine plus LPS than the subcutaneous injection vaccine. The results suggest that LPS may be expected to enhance the vaccine effectiveness and increase preventive benefits against viral infections. We presented evidence on LPS as a food, primarily based on animal tests. Thank you for watching to the end of this video. Please also watch the separate video that summarizes the evidence from human trials on the effectiveness of LPS as a food.